Okay, today's notes is on direct and inverse variation, otherwise known as directly proportional and inversely proportional. Direct proportion and inverse proportion, we've probably dealt with this in some sort of science class. You might have talked about it a little bit in middle school. But things that are directly proportional mean that as one goes up, so does the other. For example, the taller that I get, the more that I weigh. That's something that's directly proportional. As one increases, so does the other. But the opposite would be what's called inverse variation or inversely proportional, which means that as one data point goes up, the other one goes down. So it might mean that the more that you study, the more time spent studying, the less the less problems you miss on a test. Or maybe the more time spent sleeping, the less often you get sick. So as one goes up, the other goes down. So we're going to talk about both inverse and direct variation. Now, I know it says just inverse here, but we'll do inverse and direct variation. So we'll do inverse and direct variation. Oops. It's supposed to be an A. Wow. Let's try this again. That's terrible. Okay, so the formula for inverse variation is y equals k over x. And this is a formula that you're not going to have to memorize. It'll be given to you. You just need to know how to use it and when to use it. So y and x are just data points, like as one goes up, the other one goes down. K is what is called the constant of proportionality. Now, I know down there here that says the constant of variation, but everywhere else that you'll see it, well, most of the time you'll see it constant of proportionality. So in an inverse variation, the K just as one goes up, the other one goes down. In a constant, the K value will just tell us how much it's going to decrease as one goes up. It's a constant. It's a number that'll stay the same no matter what. And direct variation is y equals K times x. So you have direct variation, that's division, and direct variation, that is multiplication. Sort of easy to remember. But in most problems, it'll actually tell you whether it's direct variation or inverse variation before you start. And if you scroll down below, you can see the formulas there. They use A, and they call it the constant of variation in our book, but most other places you'll see a constant of proportionality. Okay, so let's look at some examples. So how do you know whether it is direct variation or inverse variation? So when looking at an example problem, you're going to want to put the x on one side and the y on the other side. It doesn't actually matter which one's on which side. You just need an x on one side and a y on the other. So for example, I could divide the y over to this side. So that'll cancel. So I end up with 3x equals 1 over y. If one of the variables is on the other side of the fraction, so we notice here that the x here is on top, if we were to make this a fraction, it'd be over 1. So the 3x is on top and the y is on the bottom. If x and y, being on the opposite sides of the equal sign, are on different sides of the fraction line, this is inverse variation. You can just write inverse. So when you see them on opposite sides of the fraction line, that is inverse variation. So here you'll see we didn't have to move anything around, but you'll see here that the y is with the 5 and the x is on the bottom. Just so you see this, that's y is y over 1. So top on this side, x is on the other side. It doesn't matter which one is where, as long as they're on opposite sides of the fraction line, it will be inverse. The only thing that you have to remember is that x and y have to be on opposite sides of the equal sign as well. I'll tell you right now, since direct is multiplication and inverse is division, if you don't see multiplication or division, so like in this case, we have addition, that's neither. Direct is multiplication, inverse is division. So there is neither of those. This is addition. So this would be neither. Look at a few more examples here. So again, here's an adding and subtracting. So this would be neither. Now this one's, you got to be careful with this one here. Number 5. The x is actually on the top. 4/5 times x is the same as 4x over 5. So technically, the x and the y are on the same side of the fraction line. So this is actually direct variation. Direct variation. Same thing happens here in number 7. So we see they're both on the top. Just to verify, y is y over 1. So yes, the x and y are both on the same side of the fraction line. Therefore, this is direct. And so you get the point. A lot of people get confused, like they see like a problem like number 8, and they think, oh look, they're even with each other, so this must be direct. But they forget that the x and the y have to be on opposite sides of the equal sign. So I do have to move one of these. It doesn't matter which one. I can move the x over here. It doesn't matter. So I have 6y equals 0 over x. So they are on opposite sides of the fraction line, making this inverse. So, and that's that. And 6 would be neither, and 9. They're not on different sides of the equal sign. So I would have to multiply by 9x, multiply by 9x to get the x over to the other side, and you get y equals 1 times 9x, or 9x. And as you can see, they're on the same side of the fraction line. Therefore, this is direct. What about data tables? How do you figure out if something is direct or inverse or neither by looking at a data table? Well, with a data table, you can see a couple things. You can see trends. So remember that direct variation, if one goes up, so does the other. And inverse variation, as one goes up, the other one goes down. So that gives us a head start as to which one is which. So if we look at the first one up here, you can see that the x values are increasing and the y values are also increasing. So this could be direct variation. It cannot be inverse because they're both increasing. So it can be direct. We just have to make sure. So what we do is we look at the first set of numbers here and we're going to figure out the constant of proportionality. If the constant proportionality is the same for all of them, then we have direct variation. So we're going to put this in the formula. They're both increasing, so this is direct variation. So let me just zoom in here so we have more room. Y equals k times x. And we're going to plug in x and y to figure out what our k is. So y is 4. And x is 2. If we divide over the 2, we get that our constant of proportionality is 2. So what we have to do is make sure that it exists the same for the other ones. So let's try the next one. Let's see if its constant proportionality is also 2. So we can plug in the formula, back in the formula again. So y is 16 equals k times x, which is 2. divide it over, and you'll see actually in this second one here, the constant of proportionality is 8. So that doesn't match. This does not match this. Therefore, this is neither. The only thing it could have been was direct, because they are both increasing, but since they don't increase with the same rate, the same constant of proportionality, then it's neither. So let's look at the second example. Now this one, as 1 goes up, the other one is decreasing. So this cannot be direct variation. It has to be either inverse variation or nothing, or neither. Because one is increasing and the other one is decreasing, we're going to test and see if this is inverse variation. So we do the same process as we did before. We're just going to use the inverse formula, y equals k over x. And if we get the same constant of proportionality for both of them, then we have inverse. So I'm going to plug in y is 5 and x is 1. You multiply by 1, multiply by 1, those cancel. So 5 equals k. I get a constant of proportionality of 5. That exists in the second one too. Now you can keep going if you want, but generally if the second one has the same constant of proportionality, then the rest of them will too. So same thing, except this case y is 1, k, and then 5. So we're going to see if the constant of proportionality is the same. So we'll multiply by 5 to get rid of that denominator. And 5 times 1 is 5, and equals k. And voila, they are the same. Same constant of proportionality, which means, and you can keep going with this if you wanted to, and keep trying the other ones just to make sure, but I'll tell you right now that they do. So this is inverse variation. Now, let's try the last one. As one goes up, so is the other. So this could be direct variation because they're both increasing, but we're going to check. Y equals k times x. That's the direct formula. Y is 0.5 equals k times 2. Okay, divide by 2, divide by 2. 0.5 divided by 2 is 0.25. Is my constant of proportionality. Let's see if that exists in the second one as well. Y, well actually, let's do y is 1.25 equals k times 5. Divide by 5, divide by 5. 1.25 divided by 5 is 0.25. And therefore, the same constant of proportionality. Therefore, we see direct variation. So this will be direct. Like I said, if you wanted to verify, you could check all the other ones. You would see they all have the same constant of 0.25, and so you have direct variation. So now, let's actually use it. In the last problems here, we're going to actually use the formulas to actually calculate values. So here, it's going to tell you that the variables x and y vary inversely. So we know we have inverse variation because it tells us. Let's highlight that. It varies inversely. So we're going to use the inverse formula. The first thing to do is find the constant of proportionality. So we're going to use the x and y they give us to find the constant. Then it says to find y when x equals 5. So we're going to do a couple of these because they're really all the same. But basically I use the two numbers that they give me to find my constant, and then use the constant to solve the next part, which says to find when x is 5. So I know that this is inverse, so it's k over x. I'm just going to simply substitute these in here. So 2 equals k over 2. Multiply by 2 to get rid of the denominator. And 4 equals my constant. So now I return back to the original formula. But I'm going to replace 2 in for k. This is the formula for my problem. Now it says then find x when x is 5. So when I do y equals 2 over 5, y will equal 2 divided by 5 is 0.4. And you're done. And then this would be your answer, and this would be your formula. That's your equation. Let's try one more. Use the x and y value they give me. Y equals k over x. We're still working with inverse proportion or inverse variation. I'm going to substitute them in there. 3 is y. X is 6. I multiply by 6 to get rid of the denominator, which gives me 18 for a value of k. My constant of proportionality is 18. So my equation for this problem is y equals 18 over x. This is my equation. Now I can use my equation to find any value of x and y. It tells me to find the value of y when x is 5. So I do y equals 18 over 5. Now you could certainly leave that as an improper fraction if you wanted to, but if you needed an actual numerical value, this would be 3.6. This would be your equation, and this would be your answer. Now let's look at actual real problems. So you can do 15 and 16 if you want to, but it's the same thing as above. So this is where we get into the actual real stuff. So this is real. These are real things and real life formulas in the real world. So as temperature is held constant, the volume of gas is inversely proportional to the pressure of the gas in the container. A pressure of 32 pounds per square inch results in a volume of 20 cubic feet. What is the pressure if the volume becomes 10 cubic feet? Holy cow, this seems so confusing. There's so many big words in there and everything. So let's pick apart. First of all this really is the knowledge that if I increase pressure on a bottle or something like that, that the temperature is going to go up. Okay, if I put more pressure, actually it's not talking about temperature, it's talking about volume. So if I put pressure on a bottle or if I put pressure on a balloon, the more pressure I put on it, the volume goes down, right? Does that make sense? If I put more pressure on a container, the volume goes down. So that's how it's inversely proportional. So we're going to pick this apart. First of all, it tells us that it is inversely proportional. So I know that I'm going to be using the formula y equals k over x. What you're going to do is you're going to use values that they give you, okay, to find the constant. So it gives you a value. It says a pressure of 32 pounds per square inch results in a volume of 20 cubic feet. Now it doesn't actually matter which one you put for y and which one you put for x. Just remember which one is which. So I'm going to go just sort of in order and do 32 pounds per square inch as pressure. So I'm going to do 32 here equals k over 20 for volume. So just remember which one's which. I put 32, I put the pressure in for y, and I put the volume in for x. So we multiply by 20 to get rid of the denominator. Multiply by 20 over here as well. And I get that a constant proportionality is 20 times 32, which is 640. So my equation is y equals 640 over x. And then this will serve as my formula for any other volume or pressure that I choose. So the last part here says what is the pressure if the volume becomes 10 cubic feet. So you have to remember which variable you put in for volume. If you remember over here, I put pressure. So here's 32 for pressure. I put 32 pressure in for y, and I put volume 20 in for x. So if it's asking for volume is 10 cubic feet, I know that I need to put volume in for x. So what this looks like, and let's change colors. You see this, y equals 640 over 10. Which means that if the pressure of the if the volume becomes 10 cubic feet, the pressure will be 64 pounds per square inch, or PSI. Okay, seems complicated at first, but it really is something that is pretty simple. So again, we went by, just sort of recap what we did. Inversely proportional told us we're using the inverse formula. Just like the problems above, we use the values that they give us to find the constant. Just remember which one is which. It might help to put pressure, so we put pressure as Y and volume as X, to put maybe labels on them so you know which one is which. And once you find your constant, so we had our constant was 640, then we use it to solve the problem, which is what is the pressure when the volume is 10 cubic feet. So it gives us the volume is 10 cubic feet, volume was X, so we put 10 in for X and solved. Let's try one more. Actually, let's see, why don't you try this one on your own? Pause the video, try to complete it on your own, and check back for the answer. Okay, so first off, it says that it varies inversely, so we are going to be using the inverse formula. Again, we go with values that they already give us. I don't care which one is X and which one's Y, you just need to make sure which one is which. So it says that they can harvest his crop in 20 days with 7 farm workers. So I'm going to label these. I'll do 20 days is X and farm workers is Y, just to keep track of them. So when I put this in my formula, Y is 7 and X is going to be 20. I multiply by 20 to get rid of the denominator. 20 times 7 is 140 equals K. So my K value is 140. Now, the formula, which means the equation, is Y equals 140 over X. This will serve as my formula for the problem. Now, it's going to say, how long will it take to harvest the crop if he hires 10 farm workers? Well, we have to remember farm workers was Y. So 10 will go there, equals 140 over X. Now this is a little tricky because we have them on opposite sides here. So what ends up happening is I actually need to move the X over here by multiplying by X and multiplying by X. So get rid of the denominator, giving me 10X equals 140. Then simply divide by 10. X therefore, let me slide over, X therefore is 14 days, because it said how long. And that's that. Go ahead and try some of the practice problems. There are practice problems on Big Ideas 7.1, and you can go ahead and try some of the problems there. Obviously, when you come back, we will do a few more practice problems as a class. Thanks.